Hello, and welcome to the video series on the Tour of Go exercise walkthroughs. Today's video covers the second exercise, slices, from the basics module inside of the more types, structs, slices, and maps chapter. Rather than just showing you the solution directly, I will explain all the necessary Golang concepts in context for you to leave with a deep understanding of what each and every single line of code really means. Let me summarize and interpret what the question is asking of us. We are tasked to implement the function pick. Pick is a function which receives the x and y dimensions for a picture and returns a 2D grid where each element represents a pixel's blue scale value. Specifically, the grid will be implemented by a slice of uint8 slices. The uint8 values, or the pixels inside of the grid, can take a range of values from 0 to 255. 0 means fully blue, 255 means fully white, and everything in between represents various intensities of blue. To calculate the value at each position in the grid, we'll use one of the provided functions. Let's take a look at the provided starter code going from top to bottom. The first line declares the package main. Next, it imports a package called pick from this particular path. This is a package which is not part of the Go standard library, which is why we see this fully specified import path. The Go module system uses this path to locate and download the package if it is not already present on the machine. We'll take a slightly more detailed look at the functionalities this package provides in a bit. Next up, we see the function definition of pick. It takes in the dimensions dx dy as integer values and returns a slice of slices of unsigned 8-bit integer values. Finally, the main function makes use of the pick package and calls pick.show. The function pick that we'll be implementing is passed in as an argument to show. This is legal in Go as functions can be passed around as regular values. In other words, functions are first-class citizens in Go. Let's take a look at what this pick package is all about. Typing in this URL into a web browser redirects us to the package documentation for pick. Package pick implements functions that display pictures on the Go playground. We see it has two functions, show and show image. We are using the function show. Show displays a picture defined by the function f when executed on the Go playground. F should return a slice of length dy, each element of which is a slice of dx 8-bit unsigned int. The integers are interpreted as blue scale values, where the value 0 means full blue, and the value 255 means full white. There's nothing too special here about this particular package. I would just like to highlight that the two functions of this package are capitalized. In Go, any identifier starting with an uppercase letter is exported. Other programming languages have complex visibility boundaries, often using explicit keywords to accurately define these boundaries. In Go, however, the only visibility boundary is the package, and to make an identifier visible outside of that package, we simply capitalize the first letter. To implement our function, we need to define our grid, our picture, our slice of slices. This will be the main challenge for this exercise to build up this data structure. When we run the starter code, we see missing return. So let's start by getting our code to compile and just return a dummy grid for now. Let me define grid is equal to make slice of slice uint8 of dimensions dy. This represents the variable that will return at the end, so I'll simply type return grid. Running now shows that the program exited, it compiles properly. However, it throws a runtime error. It panics with index out of range. To understand where this error stems from, let's take a step back and understand a bit better how slices work under the hood. A slice is a dynamically sized list of elements, and it is built on top of arrays, which are fixed-sized blocks of memory. Slices provide a view on top of the array and provide functionality like readjusting that view, as well as growing and shrinking the underlying array. Because of this flexibility, we mostly deal with slices rather than arrays in Go. Now, let me talk a little bit about what happens when we create an array versus when we create a slice. When we declare an array, like var a3 int, automatically the 0 value of the array gets assigned, which in this case would be 0, 0, 0. As the array gets allocated the length times the 0 value of the underlying type. Here we use int, so the 0 value of int is 0, and we have 3 elements defined. On the other hand, when we declare a slice, the nil slice gets allocated. To actually create elements or allocate underlying storage, we have 2 options. We can use a literal, like so. So now we have created a slice of length 3 with an underlying array of these particular 3 elements. The other and more common option to initialize a slice is to use the built-in make function, like we did here above. And make actually creates the underlying array with the elements of the specified length as the second argument. In our case, make allocates an underlying array of dy elements, each of which gets assigned the 0 value of the elements, which in this case is a slice of uint8. And as we've just mentioned, the 0 value of a slice is nil. So what we've done is we've fully initialized the outer slice, the grid. However, each of the rows now is still nil. And that's the reason pick.show is panicking. It's trying to index into this inner structure, which is still nil. Given this, what we need to do now is to create the slice for each row in the grid. So let me get rid of this part, and we'll say for y equal to 0, y is less than the dimension dy, y plus plus. And we'll now define the row. So again, we'll use make, row, make. Now the inner slice, it's just a slice, not a slice of uint8 of the dimensions dx. And then at the particular y index of the grid, we'll set the row. So grid at y is equal to row. Now let's try to run this and see what happens. Hey, and we actually see a fully blue picture. It's all blue because every element in our 2D grid is 0. It's fully initialized, but each element is 0, and in this particular pick.show implementation, 0 gets interpreted as the color blue. Excellent. So now let's draw a slightly more interesting picture. To do this, we'll set each element explicitly on our row. So we'll create another inner for loop. We'll say for x equal to 0. X is less than dx, x plus plus. And then inside of this inner loop, we can set the element at position x on a row to be some different value. Currently, it's explicitly set to 0, but we could set it to 255. Great, and now 255 gives us a fully white picture. If we set any value in between those two, just for the fun of it, 128, we'll see a shade of blue. Now, all that is left to do is actually use a function to compute each element. I'll simply use x times y. X times y. It's one of the functions suggested in the exercise description, but we can use any function here. We just need to make sure to wrap this in a type conversion to uint8, as x and y are both integers, and we're returning a slice of uint8. So let's wrap this in uint8. And boom, we solved the exercise. We have a nice little picture here on our hands. I would like to make one more refactor to use a for range loop rather than the classic 3-part for loop. So we'll say for y row equal to range of grid. When ranging over a slice, 2 values are returned. First, the index, and second, a copy of the element at that particular index. However, since we want to allocate each row in U inside of the loop, we can actually completely omit the row and only use the index. So let's get rid of this and then rewrite the inner loop as well using for x equal to range of row. Get rid of that. And that makes our code slightly cleaner, more Go-ish or idiomatic Go. And that's a wrap. I hope you've gotten something out of this explanation. Thank you so much for watching, and I'll see you in the next one. Peace.